Friends, today I am now going to discuss quantum particle moving in a circular orbit or quantum particle moving in a ring or circular orbit. Quantum particle, the case of a problem of quantum particle moving in a circular orbit or circular path. I mean to say, a question has come in the JEST exam about this. So today we will discuss about this problem. What was that problem? Actually, the problem was such that, let me take the pen color. The problem is, if a quantum particle is such that it has mass m, okay, it has mass m and it is moving in a horizontal circular path of radius a, so its wave function of this particle is given by psi equals root 4 by 3 pi cos square phi. Okay, get psi equals root 4 by 3 pi cos square phi. This is the wave function of that particle. Now it was asked, today we will discuss about this problem also. It was asked that whenever z component of orbital angular momentum of the particle is carried out, that means if Lz is applied on psi, then what will be the possible outcomes and what will be the corresponding probabilities. So let's start discussion about this. So today we will discuss two topics: one, quantum particle moving in a circular orbit, and if a z component of orbital angular momentum is acting on this state, then what will be the outcomes. So whenever a quantum particle moving in a circular orbit of radius a, so what is the general state of it? General wave function is such that phi equals 1 by root 2 pi e to the power iota m phi. This is the key thing to solve this problem. We have to know the general format of this wave function. But m is what? M is azimuthal quantum number or magnetic quantum number, what you will say. And phi is what? Phi is azimuthal angle. So whenever Lz is acted on it, what it will give? So let's break the wave function. Psi equals what? Root 4 by 3 pi cos square phi. What it can be written? Root 4 by 3 pi 1 plus cos 2 phi divided by 2. Okay, it can be written in such a way: 1 by cos 2 phi divided by 2. So we can write what? We can write psi equals half root 4 by 3 pi 1 plus cos 2 phi means what? Cos 2 phi means e to the power 2 iota phi plus e to the power minus 2 iota phi divided by 2. Okay, yeah. So suppose we are assuming it as constant, arbitrary constant, c into 2 plus e to the power 2 iota phi. If we take LCM, and these two will be going here, so we can write it at 2 plus e to the power 2 iota phi into e to the power minus 2 iota phi. We are taking some numerical quantities as constant. So now if we act Lz on it, Lz is acting on ket psi. If it is acting on it, what it will give? It will give Lz is acting on C1 e to the power 2 iota phi plus e to the power minus 2 iota phi plus 2. But now it is unnormalized wave function. We have to do normalization of the wave function. What is that unnormalized wave function? C1 e to the power 2 iota phi plus e to the power minus 2 iota phi plus 2. So if we do normalization of that wave function, brass psi ket psi equals to 1, brass psi into ket psi equals 1, then what it will be happening? It will be happening is such that mod C1 square e to the power 2 I phi into e to the power minus 2 I phi. Dash I means what? Complex conjugate of that exponential 2 iota phi. That means e to the power 2 iota phi into e to the power minus 2 iota phi. That means e to the power 0. E to the power 0, that means 1. Similarly, e to the power minus 2 iota phi complex conjugate of that thing means dash I, that will be what? That will be e to the power plus 2 iota phi. E to the power plus 2 iota phi into e to the power minus 2 iota phi, that will be giving as e to the power 0, that is 1. So plus 1 plus 2 square, that means 4, equals 1. So C1 mod square equals 1 by 6. So C1 equals 1 by root 6. So normalization, after normalizing it, we are getting what? The normalized form of that function, that is 1 by root 6. 1 by root 6 e to the power 2 iota phi e to the power minus 2 iota phi plus 2. So we can write it e to the power 1 by root 6 phi 2, here 2 is m is 2, plus phi minus 2 plus 2 into 1 means e to the power minus 0 into iota phi means e to the power 0 equals 1. So we can write it phi 0 in this format. Okay. So if Lz is acting on it, if Lz is operated on it, so what we can write? Lz into 1 by root 6 phi 2. So we can write Lz into 1 by root 6 phi 2 into phi minus 2 into phi 0. So if Lz is acting on it, we will get this, that whenever it is acting on it, so sorry, here another 2 will be here because there was a 2. So whenever Lz is acting on phi 0, that means Lz into this phi 0, it will give what? It will give 0 h cut, because m is what here? Phi 0 means, let me write clearly. If we write the wave function in such a way that E psi equals what? 1 by root 6 phi 2 plus phi minus 2 plus 2 phi 0. Now whenever Lz is operating in this portion 2 phi 0, let me write clearly it. Whenever we are writing it 2 phi 0, so Lz is operating on 2 phi 0, that means m equals 0 phi 0, that means 0 h cut. That means what we will get at eigenvalue of it, 0 h cut means 0 into phi 0, that is, it is giving 0. Now what will be the probability of it? So coefficient of this phi 0 is what? 2 by root 6 into phi 0. If we multiply it, if we multiply 2 by root 6 into Lz phi 0, we will get 2 by root 6 into 0 h cut into phi 0. Okay, that means 2 by root 6 into, and that eigenvalue is 0, into phi 0. That means coefficient is 2 by root 6. Coefficient is 2 by root 6 means probability of getting 0 is what? Possible outcome is what? Possible outcome Lz, whenever Lz is acting on phi 0, possible outcome is 0, and probability of 0 is what? 2 by root 6 whole square. That means what? 4 by 6, that means 2 by 3. One possible outcome and corresponding probability is 0 and 2 by 3. Sorry. Similarly, whenever Lz is acting on phi 2, so what was that coefficient? 1 by root 6 into Lz into phi 2. That means 2 is what? M value is what? 2. That means 1 by root 6 into 2 h cut into phi 2. So here possible outcome is 2 h cut, and probability is what? Probability is 1 by root 6 whole square, constant coefficient whole square. So possible outcome for that, that is 2 h cut plus 2 h cut, and probability is, let me write in good way. So another possible outcome is 2h cut, and the probability will be for that plus 2h cut will be 1 by root 6 whole square, that is 1 by 6. Similarly, if we operate on minus, LZ is operate on 5 minus 2, that means LZ 1 by root 6 5 minus 2, it will give 1 by root 6 minus 2h cut 5 minus 2. So possible outcome is what? Minus 2h cut, and probability for this possible outcome is 1 by root 6 square, that is 1 by 6. So answer will be what? Answer is such that possible outcomes for the LZ will be 0 plus minus 2h cut, and probability is for 0 is 2 by 3, and for plus minus 2h cut the probability will be 1 by 6. Okay, and what we learned from this question? We learned two concepts. One is, if a quantum particle is moving in a circular orbit or circular path of radius a, so wave function will be such that, let me write it clearly, not phi 0. Phi equals, only angular dependence term will be here, 1 by root 2 pi e to the power iota m phi. This is very important thing. And if LZ is operate on a state, it will give eigenvalue in terms of m, that is in terms of azimuthal quantum number mh cut. So thanks for watching. Thanks for today. Thank you all for patiently watching my video. Stay tuned.